So we're going to continue our talk about oxidation reduction reactions. The last video was assigning oxidation numbers. We're going to review that again today as we also show what is oxidized and reduced in a balanced chemical equation. Or even if the equation isn't balanced, you can still identify what is gaining or losing electrons. So let's remember that when we talk about reduction, reduction is when an atom is gaining electrons. And then we're going to use this little symbol E because we're going to talk about how many electrons are gained and lost a lot. So we'll just use that symbol. So in reduction, that atom's going to gain electrons, and think about it's gaining something negative. And then oxidation is when an atom is losing electrons, but it's losing something negative. So it's going to get more positive. To know what's gaining or losing electrons, that's why you had to learn the oxidation numbers. So as we go through these, we'll talk about the rules. I don't have the rules up, but you might want to print out that document assigning oxidation numbers that is posted on Blackboard under course documents. It's probably under week 1 and week 2 online folders. So the first atom is, we have to go individual atoms. The first atom is iron. So for iron, it's a solid. It's by itself, even if it's not a solid. It's by itself. There's no charge written up here. If there's no charge, it has an oxidation number of 0. I think that's the first rule that's on that. The next reactant is the oxygen atoms that are in O2. So each one of those oxygen atoms that are in there, since there's no charge written up here, that has a 0 oxidation number. And then if we come over to our product, it's not that there's an oxidation number for the whole thing. You have to find the oxidation numbers for each one of the individual atoms that are in there. So we have a rule for O, oxygen. So if you look at your list of rules, oxygen is going to be -2, almost always. And then for iron, because oxygen's -2, iron's going to be +3. The other way you could look at this is an ionic compound. You can tell because there's the metal and non-metal. So because it's an ionic compound, you can think about these in terms of charges being the oxidation numbers. So if you're having trouble figuring out how we're assigning these, there are 3 videos. There's a video for me assigning oxidation numbers. There's a tutorial video from Tyler DeWitt explaining it. And then there's another video of practicing these. You have to be able to assign these oxidation numbers because you have to see what's gaining and losing electrons to figure out what we're going to write down here. So for iron, so you look at each atom and see how it changes. It's possible that there are atoms that do not change in oxidation number. But if they do change, it's because they're gaining or losing electrons. So for iron, it's going from 0 to +3. So the oxidation number on iron is going up. So if it's going up, it has to be losing something negative. It's losing the negative electrons. So that process is oxidation. So that iron atom is getting oxidized. Then if you look at the oxygen's going from 0, let me kind of erase this one. The oxygen's going from 0 to -2. In order for that oxygen atom to go down in oxidation number, it had to gain something negative. If an atom gains a negative electron, that process is reduction. Once you have identified what's oxidized and reduced, or what those processes are, now you can answer 4 questions. The first one is, what is your species, which is going to be the atom that got oxidized? What is your species that got reduced? So let's answer these 2 first. So if you look at what got oxidized, it's going from left to right. The iron atom got oxidized. So your answer for this one is your iron. You don't need the 4 in front of it, and you don't need the phase label. You just need to say what the atom is that got oxidized. And then for reduced, this is our reduction. So what got reduced is O2. So anytime you have an element that's not combined with another element, you write it as it is. So iron's just iron. Oxygen, the oxygen atom in here got reduced, but you write O2 because that's the form that element is in. Now the 2 other parts to identify are the oxidizing agent and the reducing agent. Okay. So the oxidizing agent, and you can go back and look at Tyler DeWitt's video, talks about these 2. It's in Alex. The book is on this part. But the agents are what cause that process to occur. So the oxidizing agent is what caused the oxidation to occur. So the oxidizing agent is the O2 because the O2 got reduced, which caused the iron to get oxidized. So the oxidizing agent is what caused the oxidation to occur. So by O2 getting reduced, it caused that oxidation to occur. And then the reducing agent, kind of the same idea. It's what caused the reduction to occur. So O2 got reduced, and it got reduced because iron caused that reduction by getting oxidized. It's kind of difficult to wrap your head around what those agents are because it's causing the opposite thing to occur. In the beginning, it's good to just think about that the agents are the opposite of what the species are. But it gets a little more complicated than actually writing these out. You have to write out what each one of those atoms was in on the reactant side. It's just in this particular problem, it's a simplified version because exactly what was oxidized and reduced, that's the only thing that it's in on the reactant side. So we'll do, let's do another one of these problems. So a similar type of problem as what we just did, a little more complicated, is we're figuring out what the oxidation numbers are on each one of these, but remember, it's each one of these individual atoms. So we have a little more to figure out this time because there's more combinations of elements that are together. So the two easy ones are the carbon and the iron. So these are just by themselves. So if it's just by themselves, no charge written, oxidation number 0. Then when you have the combination of elements together, you have to use the rules to kind of work backwards and figure out the one that you don't have a rule for. So for this oxygen, in the rule for oxygen, it's going to make that oxygen -2, which is going to make this iron +3. And again, you can go back and look at the rules for assigning if you need more practice on those. And then we come over here, again, the oxygen -2, because the oxygen's -2 and there's 2 of them. The carbon's going to be +4. So let's see, to figure out what we figured out last time, we have to look at each one of these, figure out which one's going up in oxidation number, down in oxidation number, or possibly not changing. So first let's look at the oxygen. So the oxygen's -2 over here. The oxygen's -2 over here, which means the oxygen did not gain or lose electrons. So now let's look at the carbon. So the carbon went from 0 up to +4. So if it went up, if it increased in oxidation number, then it lost something negative. If it lost something negative, that's the loss of the negative electrons. So that process is an oxidation process. And then we look at the other atom that's still left over. That's the iron. So the iron went from +3 and it changed down to 0. So the iron went down in oxidation number, and it went down in oxidation number because it gained something negative. So that is our reduction. Process. So what got oxidized? So what got oxidized is the carbon. So the carbon atom was oxidized. What got reduced? So the iron got reduced. So it's just the iron atom, right? It's not this whole thing that got reduced. It's the iron atom that got reduced. So the iron atom got reduced. So notice, these two are just atoms that came from this side. The agents themselves are the reactants that were over there. So it's an agent because it's what was in that reaction chamber that caused this process to occur. So remember, the oxidizing agent is related to what was reduced. Okay, just really quick. That's the sound that you're hearing. I can't stop that from happening right now. Okay, so I think you settled in. So the oxidizing agent is what came, or what caused the carbon to get oxidized. What caused the carbon to get oxidized was what iron was in to get reduced. So the oxidizing agent, just think it's kind of tied to the species reduced, but it has to be the entire reactant that it's in. So these are atoms. These are going to be the reactants that they're in. And the last problem we didn't have any combination of different elements together as a reactant. So this one, again, looks a little different. Looks like not as simple as the last one. And then the reducing agent is associated with what got oxidized, because the reducing agent is what caused the reduction to occur. What caused iron to get reduced was that carbon got oxidized. The reactant that carbon is in is just carbon. So again, you gotta pick out the oxidation numbers. From the oxidation numbers, you figure out what atoms are changing in its oxidation number. That's how you figure out what's gaining or losing electrons. So you can figure out which process is the reduction and oxidation. Identify what the species are that are getting oxidized and reduced. These are just going to be the individual atoms that are getting elements that are getting oxidized and reduced. The agents are coming from what reactants are in the chemical equation. So these two have to be reactants. Sometimes the reactant is still just the same as the individual element that got oxidized or reduced. But sometimes what got oxidized or reduced is in part of a compound. You got to put that compound when you're talking about the agents. This is just a third example of what we've been going over, and it has a small variation of what we talked about from the last two examples. To get the most examples, you got to go look at the examples that are in the textbook. Or even the practice sheets. I gave a practice worksheet online and in the Alex homework, then those are good examples. So just starting with these ones that we have. The last time we did one of these, the first thing that we did was assign the oxidation numbers for each one of these. So it would probably be good this time to pause this video, go and make yourself assign those oxidation numbers, and then we'll come back and talk about what's oxidized and reduced. Okay, so what you should have gotten was hydrogen by itself, no charge, 0 oxidation number. When you have an ion, that ion's charge is the same as the oxidation number. So that means for this one, there's 2 of them, but ignore the fact that there's 2. That hydrogen ion has that +1 charge, so it gets the +1 oxidation number. And then this last one, it's an element by itself, no charge, 0 oxidation number. So pause again, and I want you to do what we did last time, which is figure out what the oxidation and reduction process is, and then we'll talk about what's oxidized and reduced. So for the hydrogen, if you look, the hydrogen went from 0 to +1. So if something goes up in oxidation number, is because it lost something negative. So that's our oxidation. And then we have the copper that went from +2 down to 0. Down, go up to. So for copper, that was our reduction. Okay, so now pause the video again and look at what you think these are going to be down here based on the examples that we did before. So our species, remember the species are just elements. They're not going to be the, if their elements are combined with each other, it's just the individual elements. But you have to write them as they are. So your species oxidized, you look at the oxidation reaction. It was H2, because that's just the element, not combined with another element, but that is how it exists just as itself. The species reduced was the copper, but the form that copper's in right now is the copper ion. So go back and look and make sure you see the difference between how we're writing these and how we wrote them when they were combined with another element, or when it was an element as diatomic or an element without a charge. Now for the agents. The agents have to be the reactants. This is a simpler version of the problem from last time. The oxidizing agent is what the species reduced is in as a reactant. Copper 2 plus is the whole reactant that's there. So copper 2 plus is our oxidizing agent. And then kind of the same thing for the reducing agent. It's just the reactant that hydrogen was in, and it was in that reactant. So hopefully those 3 examples of oxidation reduction will help you do some of the worked examples in the book. There's some end of chapter problems. There should be answers in the back of the book for either the even or odd. And then there's the worksheet that I posted that has a lot of examples. I'll also try to post at least one top hat question that's another kind of variation of this. It will still encompass everything that was shown in these 3 examples, but mixed together in a way that it checks your overall comprehension of this material.